Okay, so my name's Jarrett. What I'm here to talk about today is my run at rocket engineering. This was the last thing I did in high school, and as much as it is a beautiful memory, I'm here to talk about the high points and the low points and how we got through both. So it wasn't all ups. This class was definitely a lot of work. We had to learn new things like CAD, simulations. We talked to Lockheed engineers, which I'll get to later. But the main thing I'm going to focus on is the use of, how we use the invention cycle. Um, as much as we would like to say everything went great, it didn't. And I'm here really to talk about how we got through the valleys. So, everything starts from somewhere, and this is when, I guess technically we could call this the first day of class, because we had jumped literally right into it. So we didn't start with rockets. This was a kind of a surprise for rocket engineering. We didn't start with rockets. We started building wooden boxes. We thought this was a joke initially, but it really did get our feet in the water for learning new tools. So before we did any sort of working with tools or anything, we had to learn CAD. We built our boxes in CAD to begin with, to then turn that into a final product. Really to show us how things would go with the rockets, because it was pretty much the same format. So on top of learning CAD and learning the tools in different parts of the workshop, it was teaching design constraints. So we had to think of how big are the rockets we're going to build for the first half of the course, what needs to be inside, and really how to turn kind of a paper product into a physical one. How we can make a very accurate CAD drawing and turn that into, well, a wooden box. This was definitely a low point in the year. We had just begun. Everyone was super tired and ready to not do this from being on summer break. But we all got through it. I think there was a couple people that dropped, but after getting through all the CAD, out of all the CAD stuff, learning how not to use a table saw and all stuff like that, we all got through it pretty well, I think. And after that, we had to build rockets to put inside of the boxes. So we started off with fundamental rocketry. And I think this is where we really started to lose people. Besides the anatomy, I think it was really like retaking an entire year of physics in about a week and a half. Learning what part of stability matters, how to make a rocket fly straight, how each of the components work, which I'll get into here in a second, and how optimizations can be made. So how fin shape and fin surface area affects stability, and things like that. Here is one of the videos we took when we were learning about the engines themselves. So after we got the smoke alarms to stop going off, we sort of took a step back and learned how things worked. So these are a whole lot simpler than the ones that we used in the second half of the course, but I still think it's important to talk about. So you have the initial burn stage where it burns, and there's actually a hole in this piece of wood which you can't see. And then there's a time delay fuse, and then an explosion which would make the nose cone blow off. So our first rockets were far from pretty. They were covered in epoxy. We used plastic straws for rail guides, but it was a great learning experience for how different aspects go into stability, how large of a margin of error you have when it comes to the CAD design compared to the actual final project. So the simulation and CAD software we use is called RockSim. RockSim's a great tool, but it was kind of hard to get over in the beginning. It looks very simple, but the little things matter. So that what goes into stability. So when you're talking about rockets, there's two different points that you want to worry about: the center of gravity or the balance point. So where you could balance the rocket on your hand, that, and the center of pressure, which is kind of hard to explain. It's all of the surfaces on the rocket that have large impact with winds and flight. It's kind of hard to explain. We just used a simulation to kind of show us where that was, because it's kind of hard to pinpoint. And how far apart those are is a stability margin, which sounds a little confusing, but that's really what we had to focus on at this point in the year. I mean, there were many points where we were tearing our hair out, and this was definitely one of them. So we had gone already at this point in the year, I think we were maybe 2 months in, and we'd gone from the smaller 4-inch rockets to about 12 inches, which we thought was huge at the time. And I think you can even see in these, they're just covered in epoxy. We were using all sorts of weird materials to make them, and we thought this was a big deal. We thought these were the biggest that they were going to get, because we were still kind of not 100% filled in on the second half of the course, which is kind of the mainstay for what I'll be talking about. But yeah, so by the time we got done with this part of the semester, 3 out of 3 of my rockets had failed. I didn't have a single rocket that went right, which was really frustrating, because it made everyone kind of look at themselves and say, do we really want to keep going with this if we can't even build smaller rockets? We're going to get to a point where we're building rockets that could really hurt people, and do we really want to be responsible for that? But definitely at this point, it was my group mates that had kept me in the course. I was so ready to drop. I could not see myself going through with this big of an ordeal after failing already. So after a few changes, we were able to get stuff. I don't have any videos of mine because they literally hit houses right next to us. But here's a working one, just so you can get an idea of how they were supposed to look, which none of mine did, because all of mine failed. So yeah, that's how they're supposed to look. All of mine had hit houses. So at this point, we had gone on Christmas break, like high school. We'd come back, and it was kind of a shell shock, because this is when the main project was introduced. So, like the first half of the semester, we started off building wooden boxes, which I think was a good transitionary tool, but I think it was kind of a weird way to start everything, but we were kind of used to it. So with the same thing, but on a whole different scale, we used CAD to start everything out. And this wasn't really on the same scale. We researched different ideas of how to make our rocket box both fit the final rocket and be seating for the event. I think this was a 1/5 scale model of how big they actually were. Because part of this is we had to prove that they were actually going to work. So the way we did it was make a 1/5 scale model and show that it could. A 1-inch piece could actually hold the body weight of our largest group member. So with this came new design constraints. So we kind of had a rough idea of how big the rocket was going to be, but it was still a 6-foot rocket. I think our overall diameter was about 12 inches. No, well, I think it was closer to 8, but it was still very large compared to what we were used to. We went from rockets that are about 12 inches to about 6 feet, which was a huge change. So this was just to make sure everything worked. And as you can see, even a 1-inch piece was able to hold our biggest group member. So that was definitely our biggest proponent in getting our box approved, which was new to us, which soon to come was not the worst thing we had seen. So after we got done with that, we had to build a rocket to go inside the box. So really the biggest parts of our rocket was we had $700 budget, each of the groups. We included a live payload, so we had a tryout, which is like a small fish, just to see if life could survive getting launched in a rocket. I think kind of the overall theme was launching rockets to introduce life forms onto other planets or stuff like that, and to see if they could survive the launch to be dropped in other areas or planets or whatever. So we had the $700 budget, and we had to go a mile high, which to us, we couldn't even fathom how high that was. But definitely the hardest thing to do was to get started. There was only a handful of us, and we had to decide where we were going to be for the rest of the semester. So some of us decided we wanted to be on recovery teams. Some wanted to be on a payload team. I was on fins and aerodynamics with a buddy of mine, and we did the actual body of the rocket along with the fins. So definitely the hardest thing to do was to start. And this was the point where all of us looked at each other and kind of said, if you're going to drop, do it now, because we need to get our ducks in a row. Because the rest of the semester and our memories as a whole really relied on getting this started and making sure we were all on board and all ready for what was coming. So then we got to the rocket. For the first 2 weeks was mostly product research, with different supply chains, figuring out what we really were going to do. And that eventually came to our CAD simulation, or our CAD and simulation. So this was the actual rocket we figured we would make. So different aspects, like where we were going to buy the nose cone at, what material, and where we were going to source the material for the rocket tubes. We went with like a fish paper composite, similar to fiberglass but not as heavy. Whether or not we were going to make these fins or we were going to buy them. Same with these different rings, which held the motor in place compared to the larger diameter tube. Really just how big we wanted it, what sort of fins we were going to use, how many we were. And this whole thing was really trial and error. We would put different things into the simulation, see how they affected it. I think we did dozens of runs and put the best parts together to our final rocket design. And I'll go more into the design, but it's kind of hard to see with just the outline. So we did 3 separate presentations. The first 2 were design reviews. The first one was more on design. The second was products and what we were going to use. But the third one, which I'll get into here in a sec, was definitely the worst. And let me tell you why. So definitely the most stressful day of my life. We had 7 attendees for this final presentation. 2 were, my teacher and the dean of students. And then we had 5 Lockheed Martin representatives. These were people that built real rockets, and these were the people that everyone really looked up to. I think we had the head of maintenance. We had different representatives. We had real rocket engineers sitting in front of us, and they were going to give us a yes or no of whether or not our rocket would be funded. And out of the 7 people, we got 5 no's. The only 2 yeses being from our teacher and the dean of students, which was a little biased. But the biggest part we had to worry about was the 5 people we really looked up to telling us no, that our rocket wouldn't get funding. I think this took us about 2 days to get over. We had poured so much time and energy into this, and just to get kind of squashed by the 5 overwhelming no's. But eventually we got together and said, how are we going to fix this? So each of them had left us different notes. I think our original presentation for this was like 60 or 70 slides for how we were going to do everything. So each of, we got left notes, and we had to, I think I still have the document somewhere, where we wrote down the topics we were going to fix and how we were going to fix them. But it took days to get over. We all really did get kind of crushed by this. But getting over that was definitely going to be not only a hard thing, but if we didn't, all of this was for nothing. But we eventually did get everything finished. And once we did, we were all pretty happy with it. We had adjusted our CAD design. We had fixed mostly everything, and then got a secondary go-ahead on a second presentation that we did just with our teacher. So then it began. It took months. I forget the actual duration of how long it took, but it was a long time. Once all of our products got where we needed them, things like different O-rings, we had Kevlar shock cords, parachutes bigger than I am. But this is where we definitely got together with our teams and learned not only our tools, so different aspects of the workshop, but learning more about what we could do and how we could benefit the team. And it was the little things that we really didn't think about when it was on a digital side of things. But when it got physical, it really got real. Different things like the slots in the body tube. We didn't know that the fins had to have a tab that we would go down inside and connect to the smaller body tube, which sounds really weird. But it was just the little things that really made this as hard as it could be. But more ahead of things. It was really amazing to see all of our work from CAD and simulations really turn out to be a physical product. Things started coming together. Doubts started to go away. Once things started connecting, we would see that things were fitting, which really brought a smile to everyone, because this was, up until this point, was a digital thing, and it was just no after no, and we finally saw things come together. So after, I want to say 2.5 months, we went from doing these smaller 12-inch rockets to 6-foot rockets. So just kind of to help you see things along. So this is the rocket that we eventually made. This was before paint. We ended up going 3 fins. We eventually got everything connected and straight, which that was a few day ordeal. We finished this right before, or it was actually the day before the event. I think everyone in this room was field tripped out for 2 days from school to go work on these rockets, because if they weren't finished, we weren't going to be able to go to the event. But we eventually did it. We decided on black and gold, so we eventually went with that, and our rocket was done. I believe 2 of the teams did not make the deadline and were unable to launch their rockets. I'm not sure, though. I would have to double check on that. But we did meet our deadline, and yeah, everyone was field tripped out. This was, unfortunately, we had procrastinated a little bit, and crunch time really got us. But we did finally have a final product from going from a CAD design to this. So then came the launch. So we had finished the day before, and then we got there, and it was 3:30 a.m. when we got to school. We got there at 3:30, left at 4. I think we were at the event by 6 or 7. And this was time for our real review process. So we met in a really shady building. This was multiple schools that had gotten here. And this was really the point where we got a real yes or no. The original flight readiness review was, I think it's a packet of 4 pages front and back. I mean, it's a 9-point font with dozens of checkboxes. This was the point where it's go or don't go. And if you get a no here, there's really nothing you can do about it. We had electrical tools, electrical tape, stuff like that, but if your rocket did not match exactly to your CAD design, which is a lot harder than it sounds, I think we actually manipulated the CAD design to work with our final product. If they didn't match to a certain margin of error, they would not let your rocket fly, because this was a FFA event, so people there are certified to work with rockets that are going a mile high and unbelievably fast. Because if anything really goes wrong, someone could really get hurt, and safety on top of everything was their biggest concern. So they would jerk on like the fins to make sure they wouldn't come out, and it was really scary compared to what we were used to. But we did get a yes. I think we had something wrong with our wiring in our altimeter, or like the brains of the rocket. We used stranded wire instead of solid core wire, which was a complete oversight, but it was those little things that really mattered. So that was it. I think the entire thing took another couple of hours to get through that. And then we were on the bus. It was a 30-minute ride from the inspection area to where we would actually be launching. This was super remote, dirt road, going through rivers, literally, to get to the event. It's super scary. Everyone's heart was racing, and we tried to get over a little bit. But I think everyone was kind of already about to have a panic attack. This was the ride that we would remember forever, and this was the day where our whole semester would either be worth whatever we did, or if everything would just be scrapped. So, then we got to the event. It took another couple of hours. We went through another review process where they put in the blasting charges, which were pretty much 12-gauge buckshot blanks, which would blow our rocket into 3 pieces. But yeah, they finally got the rocket fueled. The rocket fuel is liquid nitrogen combined with a solid component to make a hybrid rocket motor. So once I got all that done, we were ready for launch. All the videos I took were in slow motion, so I might have to skip forward a little bit. But this was the point where everything came together. There it is. So this was a year's worth of work put together, and this, I think the flight duration was about 3 minutes. This really was the point where we brought everything together and we made a real product. At this point, we were all imagining the hours we had spent on CAD designs and almost getting into fist fights and throwing things because we could not figure these things out. And then we watched our rocket go up into the air. Another video I took, this was, I think, one of the few that I took that weren't in slow motion. This was a different groups. I think there was 40-ish rockets launched that day. But just so you can get kind of a sound comparison to how fast this really was, only 2 of these failed, but just the sound that these made, I don't think the microphone really gave it justice to just how ground shaking these really sounded. But yeah, I think it's worth listening to.
3, 2, 1, ignition.
And yeah, so that was an entire year's worth of work sent up in about 2 minutes.
3.
So, here was everyone in our group. That's me. We had all woken up at 3 a.m. Was not ready for pictures. So then came pizza. I think we'd spent 2 days in the school watching Interstellar and really just partying and trying to make the best out of this. And then we were surprised to hear that the year wasn't over yet. And we then took another couple of weeks to get some presentations together, and we went to the Fort Worth Science Museum. Took our rockets, or one of our groups had theirs explode, so we pieced theirs back together and took it. And then spent 6 or 7 hours at the Fort Worth Science Museum. We had a little expo where kids could come and play with the different aspects of the rocket, teach them about rockets. Big trifolds full of pictures and how rockets worked. This was a great time. I didn't take any pictures, but the presentations we did and the trifolds and all that was super fun, and definitely really capped off the year. But that was it. So our rocket did not quite make the goal. We went 3,092 feet, which is a couple thousand feet less than the mile goal. But we definitely did have a lot of fun. Our fish, the little tri-op that went, did survive. He made it through the weekend just fine. And yeah, this was the last class I took in high school. It was a beautiful memory that we all have. I still talk with all the guys today. And these plaques, every group made one with the end of their rocket boxes, and these are still hung in the rocket engineering department of that school. But yeah, it was a beautiful time, and as much as we wanted to rip our hair out, we still did it. We still had a good time, and we really made it the best out of it. So, really a beautiful memory. And yeah, I guess all I really have left to say is thanks for listening to me tell a story.